All right, so we're getting ready to start the demo. Yeah, it's a CAD demo, and Charlie's going to show us how to use the software. Or give us an introduction to it anyway. Yeah.
There is a handout. Yeah, there's 10 copies, so some people are going to have to share. Go ahead and pass those around.
We don't need one if you don't
I like your shirt. I like your sweatshirt.
Okay, we live? Yeah. Rivers West Demos. What you see on the bottom of the page is a table of offsets. A table of offsets is no more than a description of what the boat's going to look like from the side view and from the top view. Side view, Mark, what's the proper name for a side view? Elevation, profile, top down, they call it plan view, right? Whatever, but it's the same thing. Looking at it from the side, looking at it from the top. And from those two, you can produce a 3D boat. Your side view, they do half view, and they typically do an end view. They only do half of it, and they'll do the other half like that. The table of offsets gives you a two-dimensional picture. But if you think about the side of it, the side's going to be longer, and you need to be able to expand that, so when you lay it out on plywood, you're actually cutting the full-size pattern that you're going to wrap back and get to that. And so how do you get to your patterns is basically what you can do. And what a program like this will do is you can see the side view, you can see the top-down view, you can see the end-on view, and you can do fancy things like this. You can rotate the thing in 3 dimensions and see what your hull is going to look like. And you can also go in, if I find where my mouse cursor is. Okay, it disappeared on me. Where's my cursor? I lost my mouse. Okay, you go up to patterns, nesting, and you go, hang on, I've lost my mouse again. It's hard working on 2 screens. There we go. This is what your frame is going to look like. Let's go down to, let's pick up a straight, like chine number 3. You can see this is going to be the exact plank shape that you're going to need to lay out on a plywood to build that boat. And so once you've got your numbers, you feed them into the program, it'll do your expansions. And
So all you did was enter in the offsets?
The offsets, yeah. Yeah. So what you're doing is, like here, data. I have to.
What program are you using?
There's your table of offsets. And this is your width, your height, and your length. And if you look now, look at that handout that I gave you. Look at the bottom. You've got station A. I don't know why they numbered A. That's your bow. You got station 0, 1, 2, 3, 4, 5, and S. S is your stern. And if you look at the top line, you've got water line to shear. Oh, let me, oh yeah, that's. Go ahead and get rid of that. So let's say you've got a simple boat, something like a salt bay, right? Salt bay's got a real, like that. Like that. So this is going to be station one or your bow. And what you want is how far over and how far up. You put X's. You can impose a trend line, and then you can create your table of offsets from that. You feed it into a program, and then you can produce your patterns. One of the things, if you look at that table of offsets, underneath A, you see something that looks like 1 dash 2 1/4. Typically, they give it in feet, inches, and either eighths or 1/16. But if you look at station number 2, the second line, and what it is, it's 0 dash 1 5/8 with a plus. And that's a way to indicate less than or more than an eighth. It's a 16th. And they'll do the same thing on there's a line down there. Station number 2, the fourth line, is 1 dash 4 3/16. Come on, is it 16ths or an eighth? Which ones are you going to work with? And if you look at Gardner's boat, sometimes he gives a table of offsets with the bow left-hand side, the stern right. Sometimes he gives them the other ways. Sometimes they work from baseline. Sometimes they work from a water line. Sometimes they work from a top down. There's no consistency. And what I want to do is I want to show you a graphing program that will enable you to create a faired line, which you could then feed into this, which you could then produce your cutting patterns.
Charlie?
Yeah.
What program is this?
This is, here, let me. Greg. It's Greg Carlson's hull designer. You can go to the website and you could download the program. It might run on your computer, it might not. It depends on how much background software you have. It's an old DOS program which is updated to Windows. But this is only one of like 15 or 20 marine CAD programs which are available. Some of them are free. There's DelphShip, there's Free Ship, there's stuff like that. If you go to boatdesign.net, you can look up your software. And what the programs are used for, most people don't want to design their own boat. They've got a set of plans. Are the lines good? Are they in fact fair? And I've never seen a set of plans that didn't have mistakes in it. Sometimes the mistakes aren't crucial, but sometimes there's as much as 3/8 of an inch, 1/4 of an inch out. And for some things it doesn't matter. If it's like on the sheer, big deal, you're gonna plane it out. But in other things, let me just go into the graph program and I'll show you just how bad some of these programs, some of the plans are.
One thing I've seen is a lot of the plans don't have enough diagonals. They won't have enough, they'll
Okay.
have one diagonal.
And I never use diagonals, and I never use buttocks.
I do.
I don't even understand it. And that's the thing about lofting. Get a book of lofting and try to work your way through it. Your eyes will glaze over and you'll come away not understanding it. But if you work with side view, top view in a program, you can get it right.
The Mystic Seaport lofting book is the best one I found.
Vesties?
Mystic Seaport.
Oh, Mystic Sea. Oh, okay, there's a half dozen. There's
Yeah.
small one, Vesties like that.
Yeah,
like that.
Vesties is very confusing. There's another one that's absolutely wrong. The guy
Okay.
says he's an expert and he tells you things wrong.
Yeah, and so I try to avoid the term lofting. I try to avoid the term designing. I'm just drawing a boat, and then I'm going to make the boat. You know, keep it simple. And I don't use diagonals. I don't even understand how to use them. You know, but let me get it. Let me get into the program. And I'll show you. Hang on. Okay, let's close this out. Let's minimize this. Let's go. Where's my cursor again?
Mystic Seaport. Yeah, let me do that. I'm gonna find it and I'll tell you exactly.
Okay. This is a graphing program. This is a free graphing program. It'll work on any computer. And normally you're talking a Cartesian plot, but with a boat, oh man, here, edit. Oh, come on. Okay, I keep going. Okay, yeah. What you want to do basically, if you set up -2, we know the boat's 6 feet long, so let's go 84 inches. The y-axis, let's go -2. The up axis, let's go 20.
It's out of stock.
Bingo. Okay, now what we want to do is insert a point. Insert a point series. Look at your where look at your handout. I've got the wrong one. Yeah. What we want to do is we want to draw the shear. If you're going to draw the shear, it's 1-2 1/4. So the 1 is a foot, 12 inches, 2, 14 1/4. And so let me do. Okay, so let's put that first point in at. Okay, yeah. So let's call this the shear. Oops. We know that's at 0. We know the next point is 14 1/4. What's the next point? The next point on that is what? It's 16, right? So the next point is at 16, and how high? Is 16 over, and how high?
What's your height reference from?
It's from a water line.
Okay.
It's a 5-inch water line, unfortunately. So I basically would have to add 5 inches. And so let's do that. Let's make the correction. Oh, gosh. Man, this is tedious. Sorry. So we like that. So we're actually at 19 1/4. And so the next one is at 16. And is at 0, 11 1/4. We're adding 5 inches. Therefore, 5 and 11 is 16 1/4. The next one is 9 5/8 plus 4, so it's actually going to be, that's at 30. So that's at 14. And then 63. It's 44. It's at 9 3/4, which is 14 3/4. The last one is at 72. And that's 11 1/4, which is 14 1/2. No, 16 1/2. Okay, you can plot that. There's your, that's your plot. And then what you can do is function. Let's see. Insert a trend line. We want a polynomial. We want a second order polynomial. Bingo. There's your shear line. But take a real close look. That's not a fair line. That's not a fair line. So there's mistakes in the plan.
Are the scales of the X and Y the same?
No,
So you're getting sort of
and that actually really doesn't make any difference. What you're really looking at is this.
shape.
And what you can do now is, given that equation, how bad off is that line? You can go up here and you can do calculation. You want a table, and I want to go from 0 to 72, and I want the plot point at, let's say, 58. Bingo. It predicts it should be 1501. Oh wait, I didn't do it at 58. Okay, but okay. Let me do another one then. Sorry, I'll do it. Function. I'll do calc. Table. Let's do it. Okay, we have to do it. 0. 44. Let's do it at 44. Okay, at 44 it predicts it's going to be 14 4/5. If you look on your table at 44, or look here, 45, you can see that point really needs to be there. And what you can do is, this will give you a corrected line, and you can correct the lines, then feed them into that. And what I've done, in fact, oh man, okay, let's open. No. I want to open. Okay, I've already done this at home. This is what the shear looks like, and you can see that point's bad, that point is bad. This is a rocker. In fact, it's a really severe rocker. And there's something called second order equations, third order equations, fourth order equations. The more points that you're building in, the more wiggly you can get in the curve. How does plywood bend? I'm guessing a second order equation, that if you put, a catenary curve, that's probably how it'll bend. But in fact, he wants to have a really sharp thing, because what is he doing? He's drawing a tender. He's probably going to tow the tender. He wants the bow to be really steep to right up over the waves. And so that's a deliberate design decision. If I were building a boat, I would flatten the thing out, because I'm not trying to tow. Are the questions? Okay,
You make the program will make the little correction to get it onto the fair line, to point onto the fair line.
what you can do is you can plot your points, you can plot a trend line, then you can produce a table which will be really where it should be.
Yeah.
Then you can feed those numbers back into your program, and then work from that.
So it does all the little corrections for it.
It'll do it with corrections. Yeah.
And so then the whole design program will allow you to produce patterns.
Yes. Yeah. In fact, let me get back to, because I've actually drawn the boat.
Trick would be good. Full size. Scale.
Okay. Okay. No, I want graph. Okay, what I want is open. Okay, this is the program. You can see where I am. Okay, this is that boat. This is tiny. It's John and William Atkins' Tiny Ripple. This is the boat. Okay, that's what it looks like end on. That's what it looks like top down. And if you go into, I've got a clear old patterns, save and create. Here are the old patterns, save and create, save. I gotta get back to here. Nesting. Okay. That's what your stem looks like. That's your bow. That's your bow. That's your transom. That's what the bottom of your boat looks like. That's what the side plank looks like. Get rid of the stem, get rid of the transom, get rid of the sole. And what you can do now, flip.
Both sides.
Okay. And you can see in one sheet of plywood. Let's get rid of that. Okay. What this allows you to do with this boat, because it's a small boat, but sometimes you want to really be able to move parts around on your plywood to be able to cut them efficiently. In fact, I can cut a boat for my own use out of a sheet and a half, just by the bottom, one side, two sides, do two transoms. But this, it's useful. And what you can do, yeah, Ralph, your question?
Why don't you finish your thought?
Go ahead.
So how do you get from a scale, a smaller set of patterns to full-size patterns?
By numbers. That, what you can see right here, let's move it right there. Bingo. You're at 0. You're here. you're 16 over, you're 0 over, and you're 16 up. And this is an eighth, 16 and 3/8 of an inch. So what you do is you simply make a table, XY table. And so your next plotting point is your 6 inches and 3/8 over, your 15 inches up. And so you set your plotting points. And then you take your sheet of plywood, take a drywall T-square, put a tape measure across, come over 15 inches, mark up X, 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 spring a batten, and now you've got your exact pattern.
So you have to create that list of,
You have to create,
those yourself.
it's not going to produce that, yeah.
Yeah.
But because
Or
part,
you can find a really good unless you had a huge.
you can, yeah, but the thing is, paper patterns are nonsense because they shrink and what like that. You're much better off working with the hard material and doing your excess. Yeah,
Give it in your numbers and you just add some numbers.
yeah, you could with that. I skipped over some other stuff. Unfortunately, I wanted to get to. Just a kind of a general question. For how long have humans been building boats? Think about it.
Millions, probably, millions of years now.
A long time. What did those early boats look like?
Logs.
Okay. Were they boats or were they rafts? Rafts. What's the difference between a boat and a raft? Come on. What's the difference between a boat and a raft?
Wait,
No, more specific. Come on.
Displacement.
Displacement! Ta-da! Yep. Okay. What I was going to do, I was going to do a presentation. For how long have you humans been building boats? What did those early boats look like? Some of them were log canoes, rafts, like Titicaca, the bundles of rafts like that. Think of Thor Heyerdahl's raft. He had a sail, he had a like that, but it was really a raft because they took balsa logs. And the difference between, what's the difference between a raft and a boat? Buoyancy versus displacement. Give me if I take something like this in a pan of water and drop it in, what's going to happen?
Sink.
It's going to sink. If I take something like this, drop it in, it's going to float. This has buoyancy, but if I put this down here, I'm creating a hole in the water. I'm displacing water. I'm working with displacement. When you're drawing boats, you're trying to manage displacement. Whether it's a coracle, whether it's a canoe, whether it's a peat pod, whether it's a drift boat or it's like that, you're creating a hole in the water that's going to serve some purpose for you. It could be speed, it could be propulsion.
I thought it was pouring money.
That's where you dump your money.
We all know that.
If you're trying to manage displacement, what do you need that hole in the water to do for you? If you're building barges and you're hauling a lot of cargo, you need one sort of shape. If you're trying to go fast, you need a different sort of shape. And that's when I start drawing these patterns and I start digging into the plans, I'm saying, what is the designer trying to do with this boat? Did he in fact achieve his purpose? If I make two changes, how many changes can I make to improve it? Or at what point have I really destroyed, have I not respected the designer's intentions? And have I drawn a different boat? And so people tend to think that they got it right the first time. They don't. There's always mistakes. There's always choices. Let's do some more interactive stuff. What are the qualities of a good tender? If you're trying to build.
Are we talking a motor tender, a sail tender, a rowing tender, multifunction?
Excellent. Yeah. Okay. What are the qualities? Let's say you've got a typical sailboat, 19, 22 feet. You want a tender. What are the qualities of a good tender? Okay. Towability, right?
Doesn't want to go on its own direction.
Okay, towability. But what if the boat is small enough that you can stow it on top of on the cabin?
On a 19-foot boat?
Okay.
Well, Tika was 19 foot, and he stowed it on, it was the cabin boat when John Roosevelt sailed around the world.
Okay.
Depends on the boat, I guess. I was thinking
Towability.
19-foot.
What is if you're trying to if you've got a sailboat and you need a tender? What are some of the qualities you want in a good tender?
Stability.
Stability.
Well, then comes up initial stability and secondary stability.
Okay. And then you got initial and then second. What are the qualities?
If it's sailing or rowing, you're going to need to have good sailing or rowing characteristics. If you're going to do power, then you're going to lose your towability, but you're going to gain the ability to power. So you really got to decide what is it going to be.
Okay, rowability, if you want to use it like that. How about seaworthiness? How about sea kindliness? What's a sea kindly boat? It's probably not going to be flat bottom. It's going to be V bottom. The minute you get a V bottom boat, you sacrifice stability. And so when you have all your characteristics, you've got to make choices. And it's the same thing with any set of patterns. What are the characteristics that are important to you? Yeah. And one of the things about using a design program is you can say, geez, what am I designing for? Or what like that.
You can have 4 or 5 sets of plans.
Yeah. Basically, that's kind of. I just want you to make people aware these programs exist. That are actually really easy to use, and if you already have 3 or 4 boats but want to look into another one, you could do it on paper, because having these patterns, you can also build models. I've done this. This you can print these on paper size, glue them together, put them on your shelf, and so
Is that a free program?
it's a free program. And there's a whole bunch of free marine CAD programs. Yeah. This is one of the easiest to use because you can drop and drag lines. You don't have to feed in tables and offsets. Yeah.
In that program, can you just mention the number of chines you want?
Yeah, it'll do up to 7 chines.
Yeah, that's a neat thing too.
Yeah, right. Yeah. Okay, basically that's kind of just all I wanted to mention. Yeah. Thanks, Charlie. Yeah.